Okay, so good evening everyone. I'm here to just do a brief recap of what we covered yesterday, Sunday. Sorry, it's been a very busy day from my end, and it's only now that I'm getting to do this, but I hope you can still get some time off and maybe just go through this and ensure that you have the prerequisites for our program tomorrow. So what this is about, I will recap and maybe just highlight the file arrangement within our directory and the data formats that you must have before class tomorrow. I will also work towards maybe showing us how we configure a domain, and then I will share some of these files with you. So let's start. We are here in our working directory. I hope by now everybody can navigate to the directories. So we are in the build WRF directory, where we have several files. We have NWP and so forth and so on. Probably in your build WRF directory there are other folders as well, or directories as well. I think that we can move or just basically copy your WRF folder and your WPS folder to this folder called NWP. That is something you can do at your free time for those that have the build WRF configured. I know inside NWP there are already pre-existing folders which were copied or brought to you from my computer. If you yet don't have build WRF configured, then you don't need to delete the ones inside NWP, because we will use them. But if you already have the model configured and you have the build WRF folder and there are the subcomponents that are required, then you don't need the WRF and the WPS from my computer. So it's up to you. But anyway, so if I get into this NWP folder, we have I've arranged it such that we have these folders: analysis, data files, WPS and WPS jog, and the WRF. So let's start with the data. This is the folder that has the data we were calling initial conditions, sourced from the GFS file. If you look at any paper out there where people have done some simulations, whether it's just on WRF Chem data simulation or anything, they will always source their data from the NOAA GFS, or they will always source their data from ECMWF. They will always source their data from maybe the CMA system. Or there are just a few specific countries that we said are running the model globally and then sharing what we call the initial conditions. They plug in this data from the Transmet systems and the WMO GTS system that is used for global data exchange, and because every country is giving their input observations into that platform, these countries that do the global modeling have the responsibility of distributing this data to all the NMHSs and any other person who wants to use this data. For example, those that are in operation, sometimes you use forecast from windy.com, sometimes you even use these things on Google Apps, Apple iPhone apps to query weather and all that. Essentially what these apps do, they get APIs from these global centers that generate this data, because it's free and it's a global commodity. It's something that every country has contributed in sharing the data so that it's processed. So it's usually data that is free and available. So people and many platforms, people have APIs for querying this data real time, and they can get it and they display it. So witty.com, I don't know, ventasky.com, I don't know from where it's just for several weather apps, they just display this data. Sometimes people go to these apps, they think those guys are top notch, but essentially they just displaying data from these centers, because there's no one that can do this kind of simulation without the kind of supercomputing that those centers have invested. And it's massive. So somebody coming and claiming they have weather forecasts, yet they have just queried GFS and ECMWF. But it's live. So anyway, what are we up to? We are up to doing our simulations at high resolution, at localized, in what we call limited area models, local regions. So either in your country or regions, or a sub-country region, maybe to simulate some specific things, or you want to simulate certain phenomenon like a tropical cyclone, so you just take a very small area and you simulate for that. So these are the kind of things we want to do, and that kind of modeling, the first step requires that we process the initial conditions that we get from the global modeling centers that have modeled the whole world, and I think I've explained why this is important. So anyway, this is the folder and the data that we were querying previously. We used ncdump. We were able to see this file, and we were able to find several variables here. Several variables. We have the float longitude and latitude. It has 273 grids on the latitude box. So basically the data that I've downloaded here is data that has been downloaded for East Africa all the way to China. So we have 273 grids, or we have basically just demarcated that latitude width from East Africa to China into 273 segments, and the longitudes have also been designated as, we have demarcated 481 grids. So in total, horizontally, we have 273 by 481, that is 131,313 grids. 131,313 grids, and for each of these grids, we solve the thousands of equations that I described when we began our lesson. So there are several variables here: longitude, latitude. We have this variable, the full names are here: pressure reduced to mean sea level. We have cloud mixing ratio, ice water mixing ratio, reflectivity, composite reflectivity, and so forth and so on. V component of wind, U component, specific humidity, vertical velocity, whatever, geopotential height, and many other variables, temperature, specific humidity, ozone mixing ratio, geopotential height. These are all the variables that we do simulate and output. And I want to imagine every field, for every single field there's a variable here that you'd want to analyze. Every variable that you may want, there are so many, you are able to pick something and simulate. So most of these are diagnostic variables, but some of them are the prognostic variables, the 7 that we said, that our equations in the atmosphere are reduced to 7 variables, prognostic ones, and we are able to solve the equations and get the forecasts. After the forecast, then we can analyze those outputs and get what we call diagnostic variables. That one can be covered later. So all these are variables, probably at different levels. You can see they are at different levels: 50 MBs, 100 millibars, and so forth and so on. So many variables. So that was ncdump. We also said we can ncview this file. You can ncview this file and get to maybe view some of the variables. Maybe this variable here, I don't know what it is. Maybe let me view another one. Okay, sorry, just view another one. You can view some of these variables, yeah, so whatever variable you want to view, you can view them. The files, where they come from, that is something very important. Where do these files come from? Where do we get them from? We get them from like I've said, the GFS file, and we can actually download them. I have a script here that I've written for you guys, and you can practice downloading this data from the website. Curl is a tool that is used to download data, same as Wiget. Wiget is also something that can be used to download data. I challenge you to get the syntax of how we use this Wiget and curl, but the script has been written so that we can use curl to download the data. But first, what I do is I go into the data directory and I create a folder, yesterday's folder, because like the data is for purposes of my research and some of the things that I do, I download data every single day for the previous day and I archive it. So you can let me stop this. Let me just stop this, and then I open it in the background. Let me open it in the background. Okay, so it has opened in the background. So I want to copy these commands and run them here. Okay, so we have created a directory for yesterday. You can see this is 2025-12-07. 07 was yesterday, and then I go inside that directory. No, I go inside our current directory, which is data, and I remove everything that is there. This is just what I normally do on a daily basis. For you, you don't need this part. It's too dangerous to remove anything, so you don't need that. So we go there and we begin downloading some of these data sets. So let me just download one of them. Let me download this one. Note that I've written the command so that they can download for yesterday. This is the bash timestamp routine for picking dates automatically. If you want to pick dates automatically on the bash terminal, just using the Linux bash commands, you can configure this to do the same for today, for 10 days from today, 5 days ago. The timestamp is something that you can manipulate and do things. You can even choose to be archiving things every 3 days, for example. So let me download this one. Maybe let me download after 24 hours. So I'm downloading yesterday's file after 24 hours. It's downloading, and note that it will be some MBs, because the data we are downloading is really for 2 continents, if not 3, and an ocean in between. So it should be 23 MBs. So if we check what we just downloaded now, this is the file we just downloaded now. You can see 24 megabytes at 1932. And this data I have written for you in this script down here, a command that can be used to convert a file using WinGrib. If you have WinGrib 2 installed, you can use this to convert the grib files to netcdf files. You can also use CDO to convert the grib files to netcdf files. Remember, I've said netcdf file. The reason we want to convert to netcdf file is because probably you want to use it in a netcdf file, or you want to view it the way you are viewing it using ncview or ncdump. You know, those are some of the reasons that you can use to that might cause you to want to convert this to netcdf. So let me convert it to netcdf. Let me just, okay, I'm just copying this syntax so that I can convert the data we just downloaded, but it's not the 120. Its name is what? This one, 024 F024. So I can convert it to GFS. Let me call it 024. Yeah, like but I think the syntax is okay. So it's converting the file, and you can see all the variables that are inside there. As it's converting, it's reading them in real time, so you can see all the variables that are inside that file. And sorry, it might take some time, so I will open another terminal here and we continue working. So as the conversion is going on, I want to also show you, what else should I show here? Maybe yeah, I want to also show how to just view the file without converting it. We can also just use WinGrip to view it directly. This command here is able to view the file directly, and yeah, that is F024, so it can be used to view the file directly. Now this one is using the WinGrip. Grip files are conventional dataset formats from, you know, the NCView team, and its tool for manipulation is WGrip. We used to have WGrip 1, now we are in WGrip 2. That is used to pass the files. We can check the variables inside. We can do a few things with those kind of files. So if I, for example, check this file, these are the variables that are inside there. The same thing that we did with ncdump. So I'm now doing it with WinGrip, and you can see all these variables are all here. All of these variables are all here. Maybe we may want to even see one of them. Let me see if our conversion is complete. Our conversion is still not complete. Yeah, it's going to take some time. After it has finished, maybe we will be able to maybe process and view one of the files. So as that is going on, let us also see inside. Let's go out and see the WPS jog, which are the static files. Remember, we said initial and boundary conditions are such that we need the real-time atmospheric state now, or in what we call near real time. So near real time is like, let's say within a window of positive or negative 1 hour we should have the data. But other than that data, which is what we are processing currently, those GFS files, and you can source them from elsewhere, ECMWF, I think from the CMA system, I think from elsewhere. UKMet, they have the unified model. In Germany, they have the Acon system. That is, I think there's a global component of the Acon system, from where we can source also the boundary conditions. And a few other countries are onboarding, but they are not as many. So that is the initial state. But also defining the initial and boundary state is this set of data that I call the static files. These are the files that define, you know, the terrain, the topography, the physiographic characteristics of the Earth. In this case, we are talking about files like this one: albedo, soil type, clay fraction, crop, you know, I think erosion, some constants from FAO. I would really want to know what these things from FAO are. Yeah, some index that I don't know. Some things that I don't know. Groundwater, MODIS, land data, and MODIS data is something that is very important for the people who are in remote in geospatial sciences, geography, GIS, and so forth and so on. Lake depth for all the lakes on Earth, you know, and many of these variables: orography, soil type, drainage, and so forth and so on. So these files, remember I said, are some of the largest files that we have to process when we are modeling. What we are up to in the next class is we are going to process these data sets for the domain that we have designed to model for. We will be able to process this file. So this is why it's important for you to ensure that you have the jog file, and you can see some of these data sets are there. This terms like 10m and 30s, these are like the minutes, you know, the minutes, the seconds. So for example, we can ask, I think I have, let me ask DeepSeek here, how many minutes are in a degree? I think 60, I'm not sure, let me find out. How many minutes are in a degree? Yeah, one degree is equal to 60 minutes. So now this means if you have, like, this data is saying we have soil type at 10 minutes. Basically, this is the resolution, the horizontal resolution of the data set we are dealing with. So let's find out. So 10 minutes will be what in kilometers? Because for 1 degree we had said 1 degree is 110 kilometers. That is, yeah, known, especially over the tropics. It's 110 kilometers. As you move away from the tropics, north and south, that figure reduces, and we normally adjust that accordingly, according to the latitudes in calculation of those standard equations. So if that is 1 degree, what about, so that is 60 minutes, what about 10 minutes? So basically we should divide, I think, by 60, but it will give us something like about 18 kilometers. So this is the resolution, the soil types at that resolution at 18 kilometers. So the 30 seconds is a very high resolution, soil type data, very high resolution soil type data. You can see 0.9 kilometers. So this is under 1 kilometer. So the earth divided into 0.9 kilometer grid boxes, and we define soil characteristics for every grid. That's quite some data, you know. And you can see there are others at 9 seconds, 2 minutes, whatever. Some are at very coarse resolutions like 2 degrees. So this data is huge. In my computer it is 131 GB. That's quite some data, you know. Sorry. That's quite some data. So let's get out of WPS and see what else we have here. Remember, I've said many times over that NWP is really not about a model. NWP is a whole school of things, and it's cross-cutting. So people need to be very informed on an array of so many things. For example, you even seen in the output we are processing ozone data. You even need to understand what that is before you can even put it and configure your systems to be able to simulate that. It's a cross-cutting field, and that's why it's a specialization within the field of metrology. But we don't expect that you become experts overnight. What we are up to, at least, is for us to appreciate what goes in there, so that when we finally do our simulation and we get an output, we appreciate the journey where we have come from. Okay, so do we have our data converted? Yeah, we finally have the data. Let me see what we have here. We just converted it. It's here. Let me just be sure that it's the one we have processed. Yes, here it is. 69 MBs. That's quite some data. Let me. You can open this in Python. You can use NCL. You can use Grads. You can use whatever. Let's go Grads, because I think most of you are able to install Grads. And let's see. What's the name? It's called GFS 024. So we can sdfopen GFS 024. Not that if you don't know how to run Grads or NCL or maybe Python at this stage, then you are not. It's not like you are really, you know. People will get time to learn these things, but then 1 or 2 instances we will also need to process, analyze these data sets and make sense of them. So we will learn a bit about maybe post-processing. Maybe we could choose to do these grads that I've just opened here. Okay, so I've opened the grads file. You can see the attributes of the file. The longitudes are spanning 15 to 58. The longitudes 15 to 58. The latitudes are from -5 to 20. It seems this is a small area. It's not the whole of it's just East Africa. So maybe I my script here, I need to change the coordinates. Yeah, you can see this coordinate is 58. You just change it to whatever you want. So if you want to download all the way to China, like the previous data that we downloaded, you just change the extents here. Left longitude is 15, right longitude 135, top latitude 20. If you want to make it go up to 30 so that you cover the whole of the tropics, and bottom latitude you can put whatever, you know. So you can change Control H. Replacing things is a common feature, day-to-day feature for scholars and people in schools. You just replace things, find that and replace it maybe with the right longitude. We want it to be 135. I'm assuming that covers all the way to Asia and Kenya and East Africa. And if you want to extend it to West Africa, it's also okay. Top latitude we could go up to maybe 45, so we cover the regions. Let's go to 60. But note that the data will be quite huge, so you should be prepared, you know. So if I was to replace, it will replace all these things. But for my case, I'm not replacing, so you will choose to replace by yourself. Okay. Yeah. So back here, the data that I've opened is from latitude this to latitude this. I mean longitude 1558, latitude -1520. The level is set to the default, but there are some variables that have the GFS file has 42 ETA levels, what we call the ETA levels, the elevation threshold levels. We will talk about the horizontal grid in another time. If we get to you know, get to those details, then we will talk about how we define the elevations. Sometimes we use sigma hybrid ETA levels. We can use different types of vertical coordinates. Okay. The time for the data is today at 00. And that's what I can see here. So we can query the file and see what is inside it. There are all these manner of variables, all of this, all of this, all of this, all of this. Maybe let's display this RH. Maybe let's display at 700, so that to some places on Earth are above that 925 MBs HPM. So set display color white, set map D, set high resolution, set these ones we will learn, no worries. GX out shaded, set what. Maybe for that let's just display and see what we have. We have something displayed here. So this is the RH for this particular day. Let me display the other one that we had processed for China. So sorry, I wanted to clear this. Okay, so sdfopen. Okay, wait, let me first see the file. sdfopen, this one. now you can see this one, the coordinates are all the way to China, Asia, the Indian Ocean, and the data is for 11th, it's 30th of November. Set what was that? RH, was it RH 700? I think. No. So let me queue file and find out. It was RH or MBs. I should add MBs. I think that's what's missing. MB. Yeah. So yeah, you can see lots of stuff here. The RH fields where we have humidity for this particular day, and things are boiling down here in frontal systems. Yeah. I think that is much for grads, and I can quit this. And now we have talked about the two datasets. We have talked about the GFS files, these ones, and where you can get them, and how you can see them, visualize them. You can use the NC dump if you choose to convert them to netcdf, and you can NC view them. Yeah, we can NC view. Remember, we can NC view the file and choose a particular variable here and just maybe view it. There's no variable, there's no data. It's 0. That one is 0, so maybe check another one. This is also 0. 0 0 0 at this time. Maybe this one, yeah, like this. I don't know what I've just, okay, displaying vertical velocity. So this is the vertical velocity field that we are displaying at this point, with the legend being here. And you can use this for analysis. You can do a few things. Yeah. So that is it, I think, for the recap. Okay, very important. And I almost forgot the domains that we created. Okay, the domains that we created. So inside our build WRF directory, we should have a folder called domains. If you don't have it, make directory domains. So for my case, it will not make it because it already exists. So the -p is checking if it exists. It will not create it. If it does not exist, it creates it. So I want to I think, let me remove something in the domains. Alps. Okay. So I want to go inside this WRF Domain Wizard, and I want to run this so that I can create a domain. So we need to set our WPS folder. What is WPS? WRF Preprocessing System. This is the place that we are going to be working from in the next class, where we process the initial and boundary conditions in preparation for the model and the modeling and the simulation stage. Then we need to define where our geographical data is, the data that are called static files that define the physiography of the Earth, and then we need to define where our domains are. So my folder is here. If I say yes, it opens the window whether we choose whether we want a new domain or we open or delete a domain. So we want a new domain. I want to call it. Let's model for some place. Let's try Europe, because Yeah, let's try Europe because we prepared some domains for Asia, for Africa. Let's try Switzerland. I just randomly chose this one, and you know, it will be somewhere in the Alps. If you look at the Alps here, it's usually very cold. Those that have been around there, you may relate. So because we are way in the north, we can use Lambert. Let me first choose the area so that we can get the CRS specifications. What is a CRS? Coordinate Reference System. That is applicable. Like I said, NWP is not just about NWP, it's all manner of things, and we interact a lot with remote sensing, we interact a lot with geography, we interact a lot with several fields, so you have to even know coordinate reference system. So Switzerland should be this one. I don't want to take the whole place, so just maybe here. It's bordering France, here, Italy, Germany up there, a few other countries. And now you see we have Lambert Conformal because it can detect the area that we are dealing with. And then I want to choose no, let me first update the map. I'm told that there's a website that we can use to just feed in some details about the area we are interested in, and it will give us the name list, it will give us the projections and the details of that country. I'll ask one of us, the students who has that website, to share it with us. So I'm demarcating the area that we are going to model for. Note that this horizontal dimension will refer to the number of grids we have defined in the east-west direction. I think the concept of grids and why we need those grids is now something understandable to everyone. So with this, we have set our domain. These ones we will set at another time in class, and then we exit. So if you go back to the domains, if you go to build WRF domains, we have Switzerland, so I've just called it Swiss here, and if you go inside, it has some files that we are going to discuss in the next class. So I think that was a little bit of recap. Ensure that I'm going to zip these files. I had zipped it before, but I think I need to zip again. Let me remove this one that I had zipped so that I can zip the domains again. Zip domains.zip. Then what we want to zip is the domains folder. Yeah, so it has zipped. So I'm going to send this domains zipped folder and the videos that I've shared here. So thank you very much, and hope to see you in the next class. Thank you.